I am pleased to announce the beginning of our next session, the session 3. This session, it will be related to relationship of telecommunication, cybersecurity, and space science, and will be moderated by me, Dr. Fouad Al-Aini, and my colleague, Dr. Abdul Rahman. And we will start by the first presentation, which will be given by Ambassador Muhammad Ibrahim Nokli. Mr. Ambassador Muhammad Ibrahim Nokli, he is Senior Advisor of International Affairs. Is also the Director of Egyptian-European Council, visiting Professor of International Relations, and the member of Egyptian Council of Foreign Affairs. Ambassador Muhammad Ibrahim Nokli, he will give a presentation on speed to space, dedicated launch for small sats on Electron. Professor, please, you have the floor. You can come here.
Now, the Egyptian Space Agency, it is located in the New Cairo, in the space city, Egyptian space city. It is about 50 hectares, it means 500,000 square meters, where there should be 23 buildings. And the most, by the end of next year, it will be, we'll have also finished the African Space Agency. It will have all the African countries in this space city. The EGC has specialized laboratories for all needed tests for space. We have also the assembly integration and test center, and it can assemble 2 satellites of mass 600 kilograms at the same time. The assembly integration test center, it has all the discipline for the space activities. And the remote sensing nanosatellite, it was launched in August and November 2019. The remote sensing nanosatellite, EGSA Cube 3, it will be launched in February 2022. And the Egyptian Earth Observation Satellite, MISRSAT, it is a satellite for Earth observation, and it will be entirely assembled and tested in Egyptian ATIC. And it will weigh 300 kilograms and will be launched to be used in Earth observation with a resolution of 2 meters. The National Experimental Satellite, NextSat-1, it will be launched in the second quarter of 2022. The Space Environmental Study Nanosatellite, it will be launched also in December 2023. We have also an educational platform. This educational platform for space technology, the vision is to unlock space technology to everyone in Africa and Middle East. The objective is to building the space workforce with higher skill and to providing an experimental way for teaching and unification of space knowledge and supporting and stimulating innovation. We have 35 educational satellite, and we sign a protocol with local universities to have all this satellite for the student, and it is meant to develop the capacity at the university level and to establish technical program and joint venture.
Either you see there,
yeah,
or
okay. So it is the educational. No, we had to make. So the Space Science and Technology Portal, we have a portal for the Egyptian Space Agency, and this portal, there is a list of online space technology courses and certificates. It is, you can find all of them at the web page. It is in English, it can be in Arabic, also it can be maybe in French. The African cooperation, by April 2019, 8 African countries, including Egypt, Kenya, Ghana, Morocco, Algeria, Nigeria, South Africa, and Angola, had launched 32 national satellites into orbit, according to the annual African Space Industry Report 2020. But last year, there is Ethiopia, Mauritius, and Tunisia also who joined the club. African countries have so far spent over 4.5 billion on satellite projects, with at least 21 out of 54 African nations having a space program or in the process to creating one. At the same time, there is 125 satellites are now under development in Africa, and all expected to be launched before 2025. The objective of collaboration is to build infrastructure and to promote level of knowledge and to enhance level of African space industries and to create sustainable collaboration platform with African countries. The African Development Satellite Space Initiative, it was launched after the Cairo Declaration in November 29, where we had the heads of space agency of Nigeria, Ghana, Sudan, Kenya, and Uganda, and they launched this satellite. The initiative mission include to monitor the climate change, to demonstrate the human capabilities in Africa, and to training and capacity building scheme. The initiative also consists of two primary segments, a space segment and ground segment. And the main objective of this initiative is to respond to domestic, regional, and continental global strategies, including African space policy and strategy, announcement of African space, and AfriGeos. The preliminary specification of African development satellite, these are technical specifications of the satellite. The training course on space technology for African countries is a part of the implementation of the African Development Satellite Initiative, and the participants take courses in space project management, space subsystem, CAD2, design, software orientation. We conducted this training in Egypt from the 25 July to the 5th of August. In Egypt, we have a lot of projects in Africa. The most important are the Rain and Climate Change Forecast Center in Kinshasa, in Congo. And this center was inaugurated in 16 July 2021 to study climate change, protect from climate disaster, and training. We also have the Central Laboratory for Water Quality Analysis in South Sudan, and this is meant to, for quality analysis to reduce water pollution and monitor river levels and forecast. In Tanzania, there is a consortium of Egyptian companies who are building Julius Nyerere Dam. It is long, one kilometer long, and the summit 131 meters of high. It has a storage capacity of about 34 billion cubic meter, with a capacity of 2.1 megawatt, and it's cost almost $4 billion US. But Egypt, Kenya, Uganda have been selected as the first awardee of UNUSA access to space for Bartolomeo program. This selection is a result of their successful CLIM-CAM project, which winning countries jointly entered into the program. The three institutions have agreed to an open data policy. This will entail sharing information and images from the project to guide climate change mitigation efforts across Africa. And this is a concrete example of the African cooperation. How can it be successful if there is a good coordination and concertation? AGC also is qualified to bid for Space Development Agency Transport Layer Tranche Contract 1. And qualifying countries are treated like domestic suppliers. We are like a domestic supplier in the States. So the US has 27 countries in this category, including Egypt, Japan, and Canada. They can compete for the contract to build satellite for SDA, which released a request for proposal from satellite companies to bid for contracts to build 144 satellites for its transport layer Tranche 1 project. Right, now this is what I wanted to talk about, is what to show you our capacities and our mean and potential for training and for capacity building and research and development. The important, it is not just all these things that are in the website, but what is important, is that that we have to make a lot of efforts together. Now I'm talking about the Agreement Regional Center in Niamey, and I'm sure that not a lot of people heard about it. And this Agreement Regional Center was established in 1974 as a specialized institute of the Permanent Interstate Committee, and it composed of 9 member states: Burkina Faso, Cape Verde, Chad, Gambia, Guinea-Bissau, Mali, Mauritania, Niger, and Senegal. It is an interstate public institute with legal status and financial autonomy. The objective is food security and increasing agricultural production, improvement of natural resources, management by providing training and information. It is also a regional institute specialized in the science and technique applied of agriculture, rural development, and natural resources. So this center, it has been working since 47 years, and it is dealing with what we are dealing now with the satellite. And this is the Desert Research Center in Cairo. It was inaugurated in 1950, I mean 70 years ago. And the objective is studying all aspects related to the fields of groundwater, air, rainwater, harvesting the natural of desert land, exploring all natural and human resources, developing, preserving, and maintaining natural and human resources, combating desertification, determination the most suitable area to establish agriculture and industrial projects, and well drilling. So those two centers, it is an example about what the capacity existing in Africa and that nobody really is aware of. So what is needed, from the ICESCO, and this is only my own suggestion, not that it doesn't engage anything, this is a personal one, that we have to make a survey about all these centers, because I'm sure in the 54 countries members of ICESCO, there is a lot of similar centers, and those centers, they are working and they have accumulated experience, because the Egyptian center, it has 70 years old, and the Nigerian one had 47, so there is accumulated experience, and this experience sometimes they need to be accompanied, they need a lot of help, they need also to avoid duplication, because for the Egyptian center, for example, it has been working for ameliorating the animal production in the desert for camels. They are making inseminal artificial insemination. They make embryo transplantation to improve the quality of the animal production, the quality of meat and the quantity of milk. And it would be a good idea that we make a survey about all these centers in the 54 countries, and see what to avoid duplication and to make a lot of improvement, because they have this experience, and this experience should be exploited and should be accompanied. From second time, for the space city, this Egyptian space city, it will be needed to have a cybersecurity institute. It will have to have an institute or whatever structure for artificial intelligence, for nanotechnology, and all these new technologies. And it can be, while we have the African Space Agency, all this structure would be very helpful, because we have to make the own capacity building by their own. And we have the mean, and we have the people, we have the human capital. And as I exposed to you all the potential of the Egyptian Space Agency, just to demonstrate that we are controlling, we have all the soft and hard part of the training, and we have the necessary people, necessary laboratories, and it can be Egypt. Our target is to be a hub for training, research, and innovation. Also, what I would suggest that we use your countries study the experience of the educational satellite, and this educational satellite, it will be, we need an incubator to put all the universities together and let young people interact with each other. And I am sure that...
Professor, excuse me to interrupt you. You have 1 minute more. You have to move to the other. Please.
Yeah, okay, this is also one of challenges, in to get people. Okay,
exactly.
So what I want to say is that all this potential is available, and we are open for, in in the Egyptian agency for any cooperation. And I thank you very much indeed.
Thank you.
Thank you.
Thank you very much, professors. Now we will move to another presentation. It will be given by Dr. Jason Calaria. He is Space Exploration Sector Missing Area Executive for Civil Space. Dr. Johnson, he joined Applied Physics Lab at Johns Hopkins in November 2018 and is leading the implementation of innovative and cost-effective solutions to critical civil space challenges. Prior to joining APL, Dr. Calaria served as a multi-mission project scientist at NASA Space Telescope Science Institute. Dr. Jason, he will give a presentation about Milo Space Mission Academy, training the next generation of solvers who will address the greatest challenge on the Earth. Doctor, you have 10 minutes, please.
Okay, thank you so much. And can you see my slides?
Yes, now
there we go.
can
okay,
see
great. Yeah, great. Thank you so much. And I think you listed the wrong title. I think you listed the title for the talk after mine. The title for my talk is New Frontiers in Space Science. I'm so very excited to be here and very excited to present this talk. This is obviously a very broad topic, and I'm only going to touch on 3 examples of new frontiers in space science that I'm very excited about. And I come at this field with a bias. I'm an astrophysicist by training, and I see, one of the biggest rewards of all of our collective worldwide space exploration programs as being the discovery, scientific discovery of understanding our planet better, our solar system, understanding our galaxy, and understanding the universe much better. So I'll try and give you a couple of examples of that today. So on my first slide, I just wanted to introduce to you a little bit about the Johns Hopkins University Applied Physics Lab where I work. One of the parts of the Applied Physics Lab is something called the Space Exploration Sector. And that's a part of the lab where we develop highly complex NASA space missions and NASA space instruments. And we also partner with international organizations. We partner with industry within the United States to make critical contributions to critical challenges. For the civil space program that I'm responsible for, our primary sponsor is NASA's Science Mission Directorate and Space Technology Mission Directorate. And over the course of APL, Applied Physics Labs, almost 80 years of history in space exploration, there are many, many examples of incredible firsts. And I've just listed a few of them here. I'll just mention 2 of them. So the picture that you see in the background on this slide, that is the first picture of planet Earth that was ever taken from space. And it was taken in 1946. It represented kind of the dawn of the space age where a lot of engineers and scientists were curious about what we could do in space. And this was taken on a V2 rocket that launched from the US. And it had a camera pointed out the window of that V2 rocket that was designed and built by the Applied Physics Lab. APL also developed the precursor of modern-day satellite navigation system that was called Transit. And if you look towards the bottom of this slide, you can see many other historic firsts within our civil space program. The framework that we have at the Applied Physics Lab is really to look at the end-to-end development of space missions and instruments, and that starts with scientific research. So we have a large research staff that identifies challenges in space exploration and goes after those challenges through peer-reviewed publications. But then we have the capabilities to conceive, design, build, test, and operate highly complex missions and instruments. And of course, partnerships are essential to the success of this wheel. Here's a one-slide snapshot of some of the major missions that APL has built in the last 20, 25 years. You can see, for example, on the right-hand side, a mission called New Horizons. That was the mission that APL built for NASA that traveled to Pluto. It caught beautiful pictures at Pluto and revealed the characters of that world to us, and then flew past Pluto into the outskirts of our solar system and did a flyby of a Kuiper Belt object called Arakoth, which represents a fossil of the early universe. And if you look towards the left-hand side and the bottom of this chart, you can see a lot of the new programs that APL is developing, and I'll touch on these just very briefly in this presentation. So let me start with one of the first science frontiers, new science frontiers that I want to talk about, and that's a topic called space hazard. So space hazard refers to space-borne phenomenon or events or objects that could pose a threat to planet Earth. And the first one I want to highlight is space weather. Now, space weather refers to the radiation and energetic particles from our sun that are streaming through space, right? So to understand this, let's put our sun into context, right? You could fit 1 million planet Earths inside the volume of the sun, right? The energy generation in the sun represents billions of hydrogen bombs going off every second for billions of years, right? And so the Earth and our solar system is insignificant compared to the sun. 99.8% of the mass of our solar system is in the sun. And normally the sun has a steady state radiation that flows into space, but occasionally the sun can hiccup. And if it hiccups, you could get a solar flare, you could get a coronal mass ejection that yields millions of tons of plasma traveling at millions of kilometers per hour, and occasionally in the direction of planet Earth. And so here's a little animation that shows the solar radiation streaming from the sun. And fortunately, our planet Earth has a magnetic field, and that magnetic field protects our planet. But if we get one of these large coronal mass ejections, it can overwhelm that magnetic field. And this has happened many times in our history, and it's led to a shutdown of our power grids. It's led to telegraph lines going down. In our modern society, with our space-based assets, all of the satellites that we have in low Earth orbit, this can pose a dangerous threat to both our civil space and our national security space assets. So I think one of the new science frontiers is to identify gaps in our space weather coverage and to build new spacecraft and new instruments that could fill those gaps, so we can forecast space weather the same way we forecast terrestrial weather. And I think that's an important goal for us. Related to this, I'll mention that the most recent mission that we developed at APL is a mission called Parker Solar Probe. This is an engineering marvel. It's the first time that we've built a spacecraft that can literally fly through the outer atmosphere of the sun. And the reason it can do that is because of technology development and that giant thermal shield that you see on the front of the spacecraft. That thermal shield protects the spacecraft. It can withstand temperatures of 2,500 degrees, and it keeps the instruments and electronics behind the thermal shield in the shade, and they operate at room temperature. So it's really a marvel of engineering. We launched this mission in August of 2018, and there have been over 500 scientific publications studying space weather type phenomenon at the source, at the sun, instead of looking at it from 150 million kilometers away as we normally are from the Earth. So very, very successful mission that's directly related to space weather. The next space hazard I want to talk about is planetary defense. Planetary defense refers to the threat of asteroids hitting the Earth and impacting our society and our infrastructure. Planetary defense is, of course, an international initiative. NASA has stood up a planetary defense office, which has the goals of identifying all near-Earth objects, figuring out what they're made out of, what their compositions are, what their orbits are, so if they were to hit Earth, what the impact would be. And then third, doing something about it, right? So if there's an asteroid headed towards Earth, what technologies do we have to mitigate an impact against planet Earth? Let me show you a video. This is a video from Russia, Chelyabinsk, Russia. This is a city with more than 1 million people in it. And this is a video of an asteroid that came in and exploded over the surface of that city 8 years ago, okay? And the shock wave from this explosion led to more energy than 20 atomic bombs, okay? And there was damage in the city, there was infrastructure damage in the city, there were casualties, people were hurt by this event. Here's an example of a person walking through a warehouse and the roof just falls down right in front of him. If he was a few feet ahead of that, he would have been severely injured. Here's a woman talking to a person in the office next to her, and he gets hurled through the door while the shock wave happened. And here's a picture of a teacher talking to some school kids. And if you look at the mirror, the glass window, you can see the shock wave really impact and scare the children in the classroom. So the Earth is being hit by asteroids all the time. Once every 2 weeks, we get hit by something that's about 1 meter across. Once a year, we get hit by something that's the size of a large table. And then once a decade or once every couple decades, we can get something much, much larger. So NASA asked APL, Applied Physics Lab where I work, to build a technology that would mitigate a potential asteroid threat. And we've developed a mission called DART, the Double Asteroid Redirection Test, where we're going to take a spacecraft and we're going to fly that spacecraft at 15,000 miles an hour, and we're going to hit an asteroid and we're going to move the orbit of that asteroid. Very, very exciting mission. We've been building DART at APL for 5 years, and we're going to launch the DART spacecraft in 3 weeks. It's going to launch from the Vandenberg Space Force Base on a SpaceX Falcon 9 rocket. And so you'll be hearing a lot more about this mission if you haven't heard about it already. And it represents NASA's first planetary defense mission. Let me show you a short video of the DART mission. Okay, there it is. NASA's first planetary defense mission. And then finally, the final frontier that I'll just speak to for 1 minute here is the foundations of life. The beautiful picture of our planet, planet Earth. One of its most distinctive characteristics is, of course, its ocean, the blue marble, as you see in this picture. And for a long time, we thought that the Earth was unique because it had an ocean. It turns out that's not the case. Many of the moons in our solar system have oceans. The difference is that most of them have oceans that are subsurface oceans and not surface oceans. But as we know from life, as we know from Earth's ocean, wherever we see water, we see life, right? If you go to the depths of the oceans on Earth, where there's intense pressure, there's no sunlight, life is thriving in those environments. And so this has opened up the search for life in the universe, the search for life within our own solar system. It's provided new motivation to that thrust. And one of the destinations that we want to explore is right in our backyard, in our own solar system, and see if some of the, for example, Jupiter's moon Europa, we're building a mission called Europa Clipper, giant flagship mission to go and explore habitability there. Saturn's moon Enceladus, the middle picture, you can actually see the ocean of Enceladus venting through cracks in the ice on the surface. That's a real image taken from the Cassini spacecraft. And I would say one of the most exotic destinations in our solar system is Saturn's moon Titan, Saturn's largest moon, Titan. That picture that you see under the moon Titan there, that's a picture of a lake on the surface of Titan, okay? So the Saturn's moon Titan is exotic because of a couple reasons. One is it's the largest moon of Saturn, and it's one of the few moons in our solar system that has a thick atmosphere, okay? Saturn's moon Titan has more air than Earth, okay? It has 4 times the density of Earth's air. It also has a lower surface gravity because it's smaller than Earth. And so therefore it's the perfect place to fly, right? Imagine a world that has a lot of air and very little gravity. It's the perfect place to fly. So we proposed a mission called Dragonfly, and that mission was selected by NASA. And we're building a nuclear powered octocopter that's gonna fly on the surface of Titan. Instead of roving on the ground or orbiting the world, it's actually gonna fly. And it's loaded with science instruments. The spacecraft that you see there is about the size of a car. It's about 11 feet across. It'll come in, it'll autonomously find a safe place to land. It'll land on the surface. It's loaded with science instrument. It has drills to sample the Titan soil. It has seismometers on the skids, has cameras, has a weather station. It has a mass spectrometer, has a gamma ray neutron spectrometer to do chemical composition. And then when it's done with a certain destination, it'll pick up and fly to another destination. The moon has complex organics on its surface, has a liquid water ocean, has methane in a liquid state. It rains on Titan. So it's a very, very exciting mission to take the next step in understanding the foundations of life. And Titan, we believe, represents an analog of what Earth looked like before the biology set in. And so this is a great, great new program one of the new frontiers in space science among many, many more. So with that, I will stop and turn it over to the next speaker. Thank you so much.
Thank you very much, Dr. Jason, for this very interesting presentation and the video showing the application of space science on many fields. Now we will move to the next speaker, Professor Dr. Lehashmi Siddiqui, who is the Dean of School of Aerospace and Automobile Engineering in the International University of Rabat. Dr. Siddiqui is also serving as adjunct professor at Mississippi State University. His main research interests are in the area of light whitening materials for automotive and aeronautic application. He is now working on seawater desalination using solar energy, recycling of used water, and recycling solid materials. Dr. Siddiqui published more than 130 papers in referred journal. He will give a speech on experiences in training of aerospace engineers at International University of Rabat. Professor, you have the floor.
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good afternoon, everybody. So I will be very brief since the time is very limited. So I will present the experience of training at Aerospace Engineering School at Université Internationale de Rabat. And I will present a very interesting project done by end-year student that was done at École Polytechnique de France in Paris in the field. So for the academic courses that we have, the trainees acquire scientific, technical, and professional skills. And of course, you have open to international, with as well at the level of students and also professors, and partnership. Yeah. It has to be adapted to the industrial environment in the aerospace and automotive field in Morocco, which is a new field and very strategic to us. And also is being able to solve industrial problems and so on. Then we will see how it was done. So we have the enrollment at the first year. We have the entrance exams with the scientific baccalaureate, second year and technical baccalaureate. We have a parallel admission in the second and third year. And also we have a partnership with Mississippi State University and Georgia Tech Institute of Technology. At the fourth year, the people will go and do their Master of Science, and then they will get the two diplomas at the same time. So the international partner, strategic partners, we have Georgia Tech Institute of Technology in Atlanta. They have two centers, one in Atlanta and one in France, Lorraine. And they are symmetrical, Georgia Tech. They are symmetrical. They are exactly the same. And then we have Mississippi State University at Mississippi State. So for the academic program, of course, you have a technical background and basics, mathematics, physics, and so on. But you have to have the management and the organization skill, language and humanity. And by the way, the teaching is all in English from the beginning to the end. And also you have a professional insertion. So here is we have around 600 students, 400 aerospace and 200 automotive. And then, of course, we have mobility with universities in Europe and in the US and all around the world. So here you have some students of UAR who are doing their PhDs at Mississippi State University. They have this possibility. So we have also another, in training, we have a senior. We have a senior project design, which is very interesting. You have 4, instead of having 1 student or 2 doing their end year projects, we have 5 years that is working with the industry in a problem that is of interest to them, industrial problem. And this will be also as a training for them, but at the same time, the company will see how they are behaving. It's like interviews and so on. They see how they are doing in experience. And of course, we have some examples here. Just you have Spirit Aero System that was the Bombardier, old Bombardier company. TDM Aerospace working on titanium and things like that with Boeing. And we have Maghreb Industries and Polydesign System. This is just a few examples. So senior design, we have some programs, some projects that are being assessed. You have assessment of post-lightning strike maintenance procedure with the Royal Air Maroc. So we have all list of all projects. I will not go through them, so it's not, it's very important, but it's very important, this senior project design. At the end of the last semester, 4 to 5 students will work on a project industrial, and then they will come up with the solutions that will be applied with the company. So we have also some lab equipment. I will pass. We have the aerodynamics, subsonic and supersonic with tunnels and so on. So we have also Hopkins bar for high-speed strain. That's for crashworthiness and so on. And then we have fatigue machine as usual. And here you have other equipment, car simulator, injection things, and so on. So I will go to that. And of course, you have school activities. Students will travel abroad and visit other companies in France and other ways. So here I will present you this is just graduate last year, and she's working on, she worked on as a project on a satellite at École Polytechnique in Paris. So could you please push on the video? I can do it from here? Okay, yes, okay. There's no voice.
Technical team, please check the voice. Give the volume.
It's very interesting.
The IONSAT is a 6U CubeSat equipped with electric propulsion and developed by the students.
Could you please start from the beginning, please?
Hi everyone, my name is Zimbaudat. I am a Moroccan aerospace engineer who freshly graduated from the International University of Rabat. And today, I'm so happy and extremely delighted to be in this conference and to share with you my experience working on the IONSAT Nano Satellites project. The IONSAT is a 6U CubeSat equipped with electric propulsion and developed by the students of École Polytechnique. It has currently 15 students working on it and managed by 2 staff members from the Space Center of École Polytechnique, the project manager, Mr. Ricardo Culpari, and the technical manager, Mr. Antoine Davant. And this project has various investors, starting from startups such as Thrustme to agencies such as CNES, Onera, and so on. My tasks in my internship focused mainly on 2 subsystems, the thermal subsystem and the mechanical subsystem. In the thermal subsystem, I had the opportunity to work with my team on finding where we would have like a hot and the cold case, and we started by firstly updating the thermal model that we have to the newest structural model that we had, and then differentiate between the hot and the cold cases using like the different power dissipation and different trajectories, like especially like for the hot case, by using like the regions where we have like the maximum absolute value for the beta angle. And I believe that the results that we had at the end were pretty decent and pretty interesting to update the thermal requirement that we had before. And that is mainly like the main like the main objective of doing the thermal analysis and updating these thermal analysis again and again. And then for my my second part, working in the structural and mechanical subsystem, my team and I had fun making a mock-up that I'm gonna share with you each picture by the end of this presentation. The main reason for the creation of this mock-up was for two main reasons. Actually, not one. The first one was for educational purposes. Is like to give is to give an insight, an educational insight to the students and whoever wants to know and understand how like our satellites work, how each subsystem is connected to the other, and so on. And the second one, it was for our visual representation. By our, I mean like the IONSAT team. Whenever we go to conferences and events and so on, it was also pretty good for our investors, whenever we are meeting our investors, to give them a close idea on the final product, how it's gonna be, and to give them, like, it would be much easier to explain something when we have it between our hands. So like without any further explanations about my internship, I would just like to say that I strongly believe that this internship couldn't have been easier on me if I didn't have the basic and necessary knowledge that I've acquired throughout my years studying in the International University of Rabat, the School of Aerospace Engineering. And I thank the Space Center of École Polytechnique for this opportunity, because for me it was an opportunity to practice all the theoretical things that I've had, especially in the satellites course. It was a great opportunity to meet people having the same interests as me, and I encourage everyone who is passionate about space to follow their dreams. And yeah, thank you again to my university and to Space Center of École Polytechnique. Thank you.
And here is the satellite. Ah, okay, yeah, you closed. I just would like. This is the picture of the satellite that has been built, and it gave all the parts that are being done at École Polytechnique in France. So I would like to thank so much ICESCO and Dr. Sharif and the team who invited us and gave us this opportunity to expose this very important issue. Thank you.
Thank you very much, Professor, and also for this message from one of the young researchers. We have here many trainings, and maybe this message will, how to say, encourage them to follow this path. I will now call my colleague, Dr. Abdul Rahman. He will continue the moderation of this session.
Good afternoon, ladies and gentlemen, excellencies, honorable guests, and speakers. The space science, as we are listening, is enhancing the knowledge and revolutionizing many areas of human development. In that regard, I'm honored to introduce our next speaker here, Major General Jose Wagner Vital. He is the Defense Director of International Academy of Space Studies in Brazil. He is also the Director of Innovation and R&D at Safier ATC Limited. He is the Space Consultant of the Aerospace Committee of the Defense Material Industries Union and Major General retired of the Brazilian Air Force. He has extensive experience in the implementation of projects for satellites, launchers, and control centers in relation to the strategic program for space systems. He is an electronic engineer and a military pilot with 1,140 hours of flight on his record. He has also worked in areas related to aviation and air traffic control, from technical management of specific activities to implementation and operation. In here today, Jana Vital is presenting his considerations about the growing space business and its cybersecurity aspects. Floor is yours, Major Vital. Thank you very much.
Thank you very much for the kind introduction. And I would like to thank you, ICESCO and the Space Foundation for this opportunity. I would like to share with you some point of views. I will try to share my presentation here. Okay. So you are seeing my presentation for a moment?
Yes, we do. Please do it in a presentation mode. Yes, now it's fine.
Okay, thank you. So I will talk about some considerations about the cybersecurity aspects regarding the growing space business today. So it's very important to observe that today we have basically two kinds of business categories. We can say space to Earth business around the Earth, and also space to space business. And then this growing market, some people from Merrill Lynch, for example, and Bank of America, they used to say that we are in the space age 2.0, and we expect to reach trillions of dollars to the end of this decade. Some people from, for example, Goldman Sachs said that we will reach $1.4 trillion per year in 2030. So it's really a fast-growing market. We can see here in this chart that we can imagine that there is no upper limit if we consider space mining in the coming years. And there are many other activities, for example, cislunar economy that didn't start yet, and so on. For space mining, for example, a single rock can value $30 billion when this rock is made by platinum. So there are some concepts, for example, to use the lunar system as a transit of resource to cislunar gateways, for example, and to use this resource to make some manufacturing process in orbit. We can see a growing market also with launchers, many different flags, many different companies, many different capabilities. Also, space tourism is not a dream anymore. Actually, we have actual space tourism started in 2021. And as we can see in this chart, we have many companies, many countries already with some private companies making business plans to make many kind of works, monitoring, tracking, active debris removal, support deep space missions, in space transportation, in and on orbit servicing launch, refueling it, and so on. And in this chart from the other consultant, Seraphim, for example, we can see there are many, many companies in many segments of the economy, of the space economy, in the upstream, downstream, beyond Earth. This other way to see by another consultant company, Space Fund, we can see that we have at least 5 branches of business, and in each branch we have many, many different business models. In this chart we can see 15 different kind of business models in many, many areas. So looking at this, we can think, what about the threat? what about the hazard we can have? What about the cyber danger we can achieve in this kind of systems? And then I'd like the result of one report of the Consultative Committee for Space Data Systems. This is a committee from NASA. Many countries take part of, many agencies take part of. And I like the definition of threat they built is a function of a threat agent capability and intent to do harm, whereas risk is a function of the probability that an organization will be targeted and the harm that might be caused. So in this case, considering this definition, we can say that threat, that we use this term now along, means capability and intent to do harm, and risk is the probability to do the harm. So, considering the cyber security, we can consider that information is most valuable resource, and then the threat agents try to harm somehow the information and cause some damage in the systems, and then they act in the products, physical security, in the procedures, organization security, on the people, for example, social attacks, for example, and then they try to disrupt hardware, software, and communications in order to create a lack of confidentiality, a lack of integrity, and a lack of availability, make the information not reachable, making people to read or to get access for something that is not to do, and also to disrupt some important information, disturbing the systems. So in this way, the threat agents, they try to target the ground systems of the satellite, for example, or the ground center of the mission, the communication systems, and also the spacecraft. And they try to look for weaknesses and then reach these weaknesses and cause some system impacts, for example, in the data, in the system, the payload, in order to disturb the mission. And they disturb or destroy completely the mission. So it's really a measure of concern how to protect this. So which are the source of agents, of threat agents? We can have adversarials, for example, terrorists, criminals, foreign intelligence services, subservice or political activists, computer hackers, commercial competitors, and so on. These are just examples, okay? You can have insiders also as threat source agencies. For example, dishonest maintenance personnel, dishonest system personnel, disgruntled staff members, trusted business partners that are not so trusted, inadvertent actions of staff members. And also we can have threat sources agents from environmental, for example, natural or man-made disasters, infrastructure failure, power outage, and so on. And structural threat sources like software failures, hardware failures. So in this way, we can have two kinds of threat sources. We can have active threats that requires that the threat source to initiate a sequence of events and actively interfere with the system to attempt to exploit a vulnerability. Active threats may be carried out against the spacecraft, ground systems, and communication systems. Some examples we can see jamming, for example, attempting access and not authorized, masquerading, unauthorized modification, malicious softwares, and so on. And also we can have passive threats. For example, there are no threat source is required to actively interfere with the target system. For example, tapping of communication system. You put some device to listen, resulting loss of confidentiality. Another example is traffic analysis to determine which entities are communicating with each other without actually being able to read the communicated information and so on. Here we have an example chart for a potential threat against space missions. For example, you can have threats in space elements, system network, control centers, users, causing hardware failures and so on. Space elements, for example, space debris, replay, link jamming, unauthorized access, software threats, other kind of threats we can have for users, interception, software threats, social engineering, physical attacks. In the control centers, replay, unauthorized access, software threats, and so on. And the system network, we can have link jamming, interception, unauthorized access, software threats, and so on. Specifically, thinking about communication space communication systems, we can see in this chart that, for example, if you will have a satellite owned by a company B that act as a relay for the communication of another satellite owned by the company A, you can see that you can suffer some jamming and some attack in the RF segment of the communication. For example, you can have eavesdropping, replay, unauthorized access, traffic analysis, data modification, and also in the ground section, you can have you can be attacked in many other ways. Or, for example, denial of services, eavesdropping, replay, and so on. This means that we have many possibilities to suffer attacks. So these systems on the ground or in space, it must be protected. These are some examples. I will deliver the presentation for the organization, and then people can read it carefully. But for example, we have applicable threats that cause some impacts. And we can value, in this report from CCSTS, we can see that there are some probability. The lowest is 1, the highest is 5. And for each kind of threat, you can have the probability measure of that to occur. And we saw that there are some mechanisms to counter threat. This is very important. So this mechanism to counter threat must be taken into account when you are planning a safe space system. So here in this list, I will not read everything, but the presentation will be available. You have, for example, data corruption, ground facility physical attack, interception, jamming, denial of services, masquerade, replay, software threats, applicable and unauthorized access, tainted hardware components. So these are the typical threats that we can face when we are planning or using communication satellites. So specifically. And how to assess, how to evaluate this. So there are many different methodologies, but actually they have some steps. For example, here we have 4 steps. The first step is to prepare the assessment. And then the second step, you must conduct the assessment in identifying the source, the threat source and the events, identifying the vulnerabilities and the predisposition conditions, determine the likelihood of occurrence, determine magnitude of impact, and finally determine the risk. And this will, the specialist must issue a report and then continue to make the access. And this report is very useful for the planners and for the operators. Specifically about the mission, space mission threat assessment, we can customize that analysis to this assessment. For example, for a space mission, we can construct representative mission scenarios for, depending on the mission, of course, human space flights, meteorological satellite, communication satellite, which was our case, science missions, navigation satellites. And then as soon as you prepare the scenario for the assessment, you identify the threats to the space mission. And then after that, you will assess impact of threats on these scenarios you have interest on. After that, you can identify candidate security mechanism to counter each threat. So you try to put a barrier in order to make the mission safe and safer. But sometimes it's not possible to counterattack. So in this case, if the threat is viable and cannot be countered, it becomes a risk. So, and this risk must be evaluated in order to see if you can proceed or you need to stop the mission in planning and thinking on another way around. Or if the threat is exploitable, the system becomes vulnerable. So this is a source of attack from the cybersecurity threats. So actually, this is a short example how to access. And of course, when you need to access these threats and the cybersecurity threat, you must build a team with the specialists and the people multidisciplinary to consider this type of the mission, if communication or other one, and then try to do this careful evaluation in order to have a good planning and to have and to build a safe system. So this was some considerations I would like to present, and just to make people aware how we can proceed and how it's necessary to consider this kind of threat nowadays, when the business in this space is becoming a reality and it's a fast-growing market. So this must be considered, because safe operations, safe missions is very important. Also, to the peaceful use of the space. I am available for the questions, and if you may have, and then I would like to thank you again the opportunity. And here you can have my email address, and you feel free to contact me anytime. I will answer the questions with pleasure. Thank you very much for the opportunity again. Thank you.
Thank you very much, sir, for your enlightening on the cybersecurity issues in space business. So ladies and gentlemen, now I'm pleased to present to you our next speaker, Professor Dr. Abdul Ghani Shibuni. He is the director of the Center for Remote Sensing Applications at Mohammed VI Polytechnic University in Morocco. He's also served at Center for Space Studies of the Biosphere in France. His major areas of interest are evapotranspiration, remote sensing, crop modeling, data simulation. Ladies and gentlemen, space science enables efficient monitoring of water reservoirs, providing early warning of shortages and problems in delivery systems. Professor Shibuni, in his talk, will highlight some of these issues in water management using remotely sensed data. Please welcome Professor Dr. Abdul Ghani Shibuni. The floor is yours, sir.
Thank you very much. Assalamu alaikum wa rahmatullah. Here I will present some. Yes.
You have the screen.
Okay.
If you can, otherwise you can use this one.
Okay. My presentation is about the use of remote sensing to address the issue of water shortage in arid and semi-arid region, which is the majority of Arab and Islamic world. As it has been presented, I am the director of Center for Remote Sensing Application at UM6P. Which is new center as the university, but it is situated within a consortium of Moroccan university, or 5 Moroccan universities, including Marrakesh, Agadir, with the help of my friend Omar Halli, here present, and Rabat, Qunitra, Bni Millal. I think the spirit was, let's bring the competency together, the resources together to make a difference, because after spending 37 years abroad, when I come back to Morocco, what I found out that they are very good scientists in several domains, but they are isolated. So this initiative, with the help of the funding of UM6P, we put together this group of scientists working on the issue of remote sensing, water resources, etc., etc. So basically, let me bring you to earth about the issue of water. I mean, the issue of water is very critical, and everyone is struggling. I mean, every government is struggling to put in together a policy that ensures economical growth while maintaining, while saving water for future generation. I think by the emergence of remote sensing data, the question is how a result obtained for such data can feed the formulation of public policy. So we are within the science policy dialogue, which is a little bit weak in the Islamic and the Arab world. So the observation, I think in environmental science, in all other science, I think the big advances that the humanity have done is always related to new source of data, new source of information. The emergence of remote sensing data push us to rethink our way of addressing the problem. However, I would like to emphasize here that remote sensing data, even though that it is powerful, it is useful, is not meant, it should not replace the ground truth. The reality is the ground, it's not the satellite. Especially people who know a little bit about what the satellite is really measuring. We are measuring through satellite data a proxy of variable of interest. For example, we saw the colleague presenting about vegetation growth, etc., etc. We are measuring reflectance. And the answer is the biomass, it's not the reflectance. So how to go with from the biomass to the reflectance? This is the key issue. And the example about radar, we are measuring single scattering albedo, okay? But we are interested in soil moisture. How we go from soil moisture to, so what he said, we go from the original remote sensing data to the variable of interest, and here there are a lot of possibility. There are empirical possibility, but empirical possibility, you cannot transfer it from one side to another side. If you calibrate it in one side, you cannot move it to other side. So you need a little bit more technicity in order to take the maximum advantage of this powerful tool, which is remote sensing data. In our research strategy, we think that the best way of taking fully advantage of remote sensing data is through the synergy. The synergy between the ground data, which is the reality, between modeling processes, because we are all interested on predicting what will happen. Satellite data cannot predict. It measures whatever you see. So you need strong and powerful model that can be, driven by remote sensing data to give you this possibility of predicting. So remote sensing data, now we have a huge set of data. In my only career in NASA JPL, we're basically treating data using laptop. But now with the amount of data that exists, and at the same time, the emergence of artificial intelligence, I think the best strategy is to couple remote sensing data, artificial intelligence, and data science, predictive modeling, and ground data. The problem in putting together this synergy is the fact that the funding agency, they don't like to fund this, which is the reality. We have very hard time in having a funding to collect the data because it's not sexy for the funding agency. Without this, we can't do anything. We can provide you a very nice picture, but in terms of quantitative remote sensing data, in terms of providing information that is useful both for the manager and for decision maker, you need this. We need, I think if you see all, I have been involved in EOS era, 20 years ago with NASA. The first thing that we did is we had an observatory in the US to validate our model, both process model or what we call inversion model, how to extract the variable of interest from the signal. So if you don't have this, we can't do anything. So anyhow, let me go to the water balance. Thanks to technology, if you take all the components of water balance, which is the storage, precipitation, evaporation, and runoff, all these variables, this variable, we can approach them through remote sensing data. Here, for example, the precipitation, there are trim and other satellites, snow, there are vegetation, MODIS, Sentinel, etc., etc. So all the variable of interest to have the water cycle can be approached from remote sensing data. But it is not enough. Remote sensing data alone, it's not enough, especially to do quantitative business. I will give you some example here about what we have done in terms of snow. What we measure in satellites regarding the snow is the surface covered by the snow. It is not the variable of interest. What we are interested on is the equivalent of water that is in the snow. This is what we need. And to do this, we need to have some serious modeling and serious inversion issue. And, just to see the situation of snow in Morocco, global change is here. You can see the dynamic during 20 years of snow cover in Morocco. This is the climate change is here. We are running short of water, definitely in this country. And thanks to NASA satellites, NASA daily satellites, we, for the first time, we correlate the snow cover with the dynamic of groundwater. For years, the groundwater was something that we cannot have access to it. But now with new emerging satellites, we have some good information so we can have a clue of how the sustainability of water is about and how we can better manage the water issue. My friend from Egypt will be happy because we have done, I spent a couple of years in Egypt actually. We have done some study in Egypt following the level of Nile River, and we were very happy that we developed a model that we can, from InVisight, which is European satellite, we can provide us the dynamic of the river discharge, and we had people working with us collecting the data so we can be sure. Let me tell you one thing. As a scientist, I can publish a paper, and it happened to me. I can publish a paper today. 3 years ago, I can publish another paper saying that what I have done is wrong. I have no problem with this. However, if the issue is to feed the public policy, okay, where life of the population depend on this decision, we cannot afford this exercise. We have to be sure about what will deliver to the decision maker. This is very important. always Egypt. I was there in 2008, actually, with colleague Egyptian. It was during the negotiation about water part of Egypt, etc. And we have done a very good job in estimating the quantity of water that has been used for the entire country, which is about 30 billion cubic meter of water is consumed by irrigation. I don't have time to go into the detail of this to see that there is huge variabilities due to the management, etc. Other thing that we can go by coupling, drought. A lot of people talk about drought, but the most important drought is the lack of water at the root zone. This is what it makes a real drought, because this is what affects the vegetation. It's not surface drought. And for this, we cannot have it through satellite alone. So we need this synergy approach that I talk about in order to get this information about the root zone soil moisture, where we can make some early warning system in a given area. So let me conclude here. I think that we still need an innovative, comprehensive, integrated research effort that bring together people from different disciplines, not only from space science, but from other disciplines, in order to address the societal issue. Second, this new technological capability, it's powerful, but it has to make full use of it. It has to be coupled with other technology. I talk about artificial intelligence. There is some technology based on isotopic techniques, which is very powerful for water. So we need to bring together this expertise to solve a real-world problem. We need also the cooperation is very important. You need to define, or I think here as ICESCO is the good platform to put together research, innovation, and education platform for better management of natural resources in Muslim and Arab world. Finally, this mechanism, cooperation mechanism, should be sustained, because the problem that we had in general is we fund a project for 3 years. When the money is dry, nothing left. So in the conception at the beginning of the project, we should think about the sustainability of it. It has to be driven by value of equity, fairness, and respect. A lot of people talk about sustainable development, but I talk about cooperation, sustainable cooperation. Sustainable cooperation is when the interests of all the parties are respected. And I always say that we need the four co: the co-construction or the co-building of the project, the co-funding of it, the co-implementation, and co-evaluation. Thank you very much. The time was okay?
Yeah, I think so. Thank you, Professor Cheboni, for your excellent words on water resource management. So now we will move on to our next speaker, Professor Dr. Zuhir Bin Khaldoo. He is the president of the Moroccan National Committee for Astronomy. He's also president and founding member of the Arab Astronomical Society. In 1985, Professor Bin Khaldoo co-established the first research lab in astrophysics in Morocco. He has a lot of experience in astronomical science, and in 2007, Professor Bin Khaldoo worked on the creation of the first professional astronomical observatory in Morocco. So, he is also a member of the International Astronomical Union. Due to his services to the space science, an asteroid bears his name, that is Bin Khaldoo asteroid 133892. So today, his talk will help us peer into the space with the Moroccan Okemedan Observatory, which he is heading, which is the topic of his discussion as well. Please welcome Professor Bin Khaldoo.
Okay, thank you to ICESCO for inviting me and giving me this opportunity to present our success story in Okemedan Observatory. I will take the advantage of translation facility to give my talk in French, if you permit. Ok. L'Observatoire de l'Okemedan, dans son allocution d'ouverture, Monsieur le ministre, on a parlé. C'est maintenant un acquis pour le Maroc, mais pas seulement, un acquis pour toute la région. C'est en effet, après maintenant une trentaine d'années d'efforts d'une équipe de recherche dans une université marocaine, nous avons pu avoir un observatoire qui fait parler de lui par ses découvertes et qui ouvre l'opportunité pour les chercheurs marocains de pouvoir intégrer les sciences de l'espace dont on parle aujourd'hui. Alors, pour ma présentation, je vais d'abord présenter brièvement l'observatoire et puis, dans la deuxième partie, je vais parler des fils, des spécialités qui sont en relation avec les sciences de l'espace. Alors, au Maroc, il y a quelques universités qui s'intéressent à l'astronomie et à l'astrophysique, où il y a de la recherche et aussi de la formation. Il y a l'université de Marrakech avec son observatoire, l'université de Rabat, de Casablanca, de Oujda et l'Akhaouine Université, où il y a une activité surtout d'éducation et de dissémination de l'astronomie auprès du grand public. L'observatoire de l'Okemedan est managé par un laboratoire, le laboratoire de physique des hautes énergies et astrophysique, structuré en deux groupes, comme vous le voyez sur ce slide. Le groupe High Energy et physique théorique et le groupe astrophysique et astronomie. Il y a 24 chercheurs seniors, dont 15 sont permanents et 9 associés. Et nous avons donné une importance première à la formation dans ce domaine au Maroc. Et vous voyez que maintenant, nous avons près de 40 étudiants en doctorat. Et chaque année, nous avons une formation de master dont l'effectif est de entre 24 et 30 étudiants en général. Alors, le titre de ma présentation s'inspire en fait d'un article que nous avons publié dans Nature Astronomy en 2018, où on nous a demandé en fait de parler de cette expérience, étant donné le succès qu'a connu l'Observatoire, vu qu'il a commencé à parler de lui, surtout après la fameuse découverte du système exoplanétaire TRAPPIST. Là, dans ce slide donc, publié dans cet article, on voit l'évolution des publications en astronomie et astrophysique d'une façon générale au Maroc. Alors les données, évidemment, peuvent être discutées. On ne peut pas, avec toute rigueur, faire réellement la statistique de tout ce qui est publié, mais avec quelques mots-clés et quelques moteurs de recherche, Web of Science ou NASA, ou la base de données NASA ADS, on peut avoir des indications. Et donc là, vous voyez deux courbes, la courbe des articles publiés, mais surtout ce qu'il faut suivre et ce qui est révélateur, c'est la courbe des citations. Et vous voyez que depuis les années 2000 en particulier, il y a une augmentation importante à l'échelle nationale, au niveau du Maroc, dans ce domaine-là. Et si on prend que les publications relatives à l'Observatoire de Lookhaven, vous voyez que l'évolution est encore plus spectaculaire en termes, comme j'ai dit, de citations. C'est ce qui est le plus important. Vous voyez que depuis 2016, les citations augmentent d'une façon très intéressante. Vous voyez aussi la courbe des indices, des différents indices qui servent à évaluer la recherche scientifique. Et ici, l'un des plus importants est le H-index. Et vous voyez qu'il y a, pour ce qui est de l'Observatoire de Lookhaven, une augmentation quasi exponentielle ces dernières années. Alors, l'Observatoire de Lookhaven, actuellement, abrite 5 coupoles. Il y a la première coupole qui a été construite en 2007, la coupole principale, où nous faisons actuellement des observations sur la variabilité des étoiles. Et il y a, dans l'ordre, la coupole MOS, pour Moroccan Lookhaven Sky Survey. Alors, cette coupole, il y a un télescope de 50 cm dédié à la détection des objets, des Near Earth Objects, et astéroïdes et comètes. Et grâce à cette coupole, l'Observatoire de Lookhaven se classe maintenant parmi les meilleurs au monde dans la détection donc de ces petits objets du système solaire. Alors ensuite, il y a eu l'expérience Renoir, j'ai en parlé tout à l'heure. C'est une expérience avec des collègues américains de l'Illinois, de l'Université de l'Illinois, dédiée au space weather, à la météorologie de l'espace. Il y a ensuite, en 2015, 2 coupoles qui sont venues renforcer l'observatoire, une en coopération avec l'Université du roi Fahd ibn Abdelaziz en Arabie Saoudite, et dédiée à l'observation de la Lune, du Soleil et de la Lune, et une coupole en coopération avec la Corée du Sud, je vais en parler aussi par la suite, dédiée aux débris de l'espace, entre autres, et donc en relation avec les études spatiales. Et ensuite, la dernière coupole installée est celle nommée TRAPPIST-Nord. TRAPPIST-Nord, comme je l'ai cité tout à l'heure, c'est un télescope qui a découvert le système, je dirais, le plus important d'exoplanètes, avec 7 exoplanètes, dont 3 sont situées dans ce qu'on appelle la zone habitable, c'est-à-dire propice à l'existence de vie. Voilà, dernièrement aussi, grâce à la coopération avec un groupe marocain très dynamique d'amateurs d'astronomie, d'astrophotographes, nous avons installé un abri avec 6 petits télescopes, et donc ça va rapprocher les 2 communautés professionnelles et amateurs à travailler ensemble dans le domaine de l'astronomie et d'astrophysique. Alors tout ceci a pu se réaliser grâce à une large coopération internationale. Alors j'en ai cité ici quelques-unes, peut-être que ce n'est pas complet ce slide-là, mais ça vous montre qu'il y a une coopération internationale très diversifiée entre l'Europe, évidemment, vu les liens historiques du Maroc avec la France, la Belgique et la Suisse, en particulier l'Espagne aussi avec les îles Canaries, et aussi avec les États-Unis, l'Australie, la Corée du Sud, et maintenant il y a la Russie qui est aussi avec laquelle nous avons une convention de coopération aussi dans le domaine des débris de l'espace. Alors nous avons aussi accordé une importance à notre ancrage régional avec la coopération avec l'Afrique, et nous avons été à l'origine avec quelques collègues de la création de cette initiative africaine pour les sciences planétaires et de l'espace. L'Afrique, comme vous le savez, a été sélectionnée, a été choisie pour l'organisation en 2024 pour la première fois sur le continent de l'Assemblée générale de l'Union astronomique internationale. C'est un événement très très important. Il aura lieu à Cape Town, en Afrique. Et la semaine dernière, nous avons organisé un forum pour préparer cet événement de grande importance d'une façon aussi grande que possible. Et enfin, je parlerai aussi de l'Arab Astronomical Society. C'est une société que nous avons, c'est une société une association d'astronomes professionnels arabes qui a été créée en 2016 et localisée, le siège de la société est au Maroc, pour aider les chercheurs arabes de travailler entre eux, de communiquer entre eux, etc. Alors, l'une des activités principales de cette association, c'est l'organisation d'écoles. La dernière école vient d'être clôturée. Elle a eu lieu à l'observatoire de Khatamiya en Égypte. Et la première école a eu lieu en 2016 à Marrakech. Et ici, je profite de l'occasion de ma présence pour lancer un appel à l'ICESCO pour soutenir ce genre d'activité. C'est une école de formation et en astronomie, astrophysique, mais évidemment, on en a parlé pendant ce forum plusieurs fois, la formation dans les sciences de l'espace peuvent aussi également faire l'objet des écoles organisées par la race. Alors, l'observatoire de Lookhampton est en relation avec les sciences de l'espace, au moins par trois thématiques, les space débris, le space weather et l'utilisation des satellites pour les gamma ray bursts, les sursauts gamma, qui sont des indicateurs très importants pour l'évolution de l'univers. Alors, brièvement, ce qui s'appelle OL, pour Optical Wide Field Patrol, est un télescope de 50 cm avec une monture très rapide qui permet d'observer en premier lieu, il fait partie en fait d'un réseau de 5 télescopes qui se trouvent autour du monde et dont l'objectif est de suivre tous les débris qui présentent un risque de collision avec la Terre et en particulier les débris de satellites. Donc c'est un programme initié par la Corée du Sud et nous avons donc rejoint ce programme-là en 2015. Voilà donc le télescope avec sa monture situé sur l'observatoire de Lookhampton. Alors, sans trop rentrer dans les détails, l'observation des satellites et des débris de l'espace est importante. On a parlé dans l'une des présentations qui m'a précédé, avec notamment l'expérience DART pour faire exploser et changer la trajectoire d'un astéroïde qui risque de se collisionner avec la Terre. Mais en fait, il y a plusieurs autres risques. Et plus on fait des observations, plus on peut évidemment pas écarter le danger, mais au moins se préparer à ce genre de danger. Donc je passe un peu sur les différentes thématiques qui sont développées. Alors, au-delà, évidemment, des thématiques scientifiques, nous accordons une importance particulière à la formation, au transfert de technologie. Et donc, dans chaque accord que nous faisons avec nos partenaires, nous tenons à souligner cette composante très importante de coopération scientifique, mais aussi de formation des jeunes dans les différents champs disciplinaires avec lesquels on collabore. Alors, pour plus de détails, là aussi, on peut se référer à une publication sur cet aspect-là qui a été faite à l'occasion de l'Assemblée générale de l'Union astronomique internationale et où on détaille les objectifs de cette expérience AOL. Il y a aussi ce qu'on appelle Renoir et ICON. ICON est un satellite qui est venu en fait compléter les observations qui se faisaient depuis le sol. Alors le Space Weather, on en a parlé plusieurs fois aussi dans ce forum. C'est une thématique qui est de plus en plus importante pour diverses raisons. Pour, entre autres, les perturbations des communications satellitaires, mais pas seulement, Je vais essayer de faire vite pour finir. Donc voilà, c'est une thématique qui a démarré dès 2010 et surtout qui a vu une augmentation intéressante à partir de 2013 avec l'installation d'une expérience qui s'appelle Renoir et dont l'objectif est de monitorer, de suivre l'évolution des vents ionosphériques qui sont des indicateurs importants pour la météorologie de l'espace. Là aussi, il y a des références sur lesquelles vous pouvez vous référer pour en connaître plus sur cette thématique-là. Les instruments installés à l'observatoire sont de deux types. Une caméra All Sky pour mesurer pour ce qu'on appelle les afterglows et aussi un interféromètre avec un skyscanner qui permet de mesurer l'évolution des hautes couches atmosphériques en termes de particules ionosphériques.
Professeur, je suis désolé de vous interrompre, mais on est déjà à 15 minutes. Si vous pouvez clôturer là, s'il vous plaît.
D'accord. Donc je vais conclure. Je vais essayer de conclure rapidement. Je passe sur les détails de l'expérience Renoir. Cette thématique au sein de l'Observatoire a été très productive, avec plusieurs publications scientifiques, avec la soutenance d'un doctorat qui sera suivi l'année prochaine avec aussi une autre soutenance. Il y a, comme je l'ai dit, le satellite ICON pour lequel, M. Chebouni en a parlé tout à l'heure, il est important d'avoir les mesures au sol et les relier aux mesures qui se passent dans l'espace. Et là, nous avons pu valider en fait les données de ce satellite ICON qui se trouve au-delà de 300 miles au-dessus de l'ISS et qui permet de mesurer la même chose que l'expérience Renoir que nous avons à l'observatoire et dont j'en ai parlé tout à l'heure. Alors, il y a le satellite SWORM qui est une coopération franco-chinoise que nous avons rejoint avec la signature d'un accord avec le CNES pour installer une antenne terrestre de suivi des informations, d'indicateurs pour ce satellite. L'installation de cette antenne a été faite à l'observatoire de Lukemden. Voilà, c'est celle-là. Et ceci, au-delà de l'installation, encore une fois, sur l'observatoire d'instruments de mesure, c'est surtout ce qu'il y a derrière, c'est-à-dire la coopération qui est générée avec le CNES dans ce domaine-là. Voilà, bon, je pense que la présentation sera à votre disposition. Il y a plein d'informations que vous pouvez compléter par rapport à ce que je viens de dire. Et dernièrement, nous avons aussi donné une importance à la coopération avec le secteur privé dans le domaine de l'espace en signant une convention avec une start-up française qui s'appelle Spaceable et qui est intéressée en fait par les observations qu'on fait. Et donc, nous allons collaborer en contrepartie. Là, vu que c'est le secteur privé qui génère de l'argent, ils vont pouvoir prendre en charge des étudiants pour le doctorat sous forme de bourse, de mobilité, etc. Voilà. Donc, on peut conclure que l'Observatoire de Lukemden a tiré profit de deux choses. La première et la principale, c'est sa situation géographique et les conditions très favorables à l'observation astronomique à partir du site, mais aussi au dynamisme d'une équipe de chercheurs qui a absolument cru en la possibilité de développer cette science au Maroc. Et tirant profit donc de cette situation-là, ce groupe a pu augmenter régulièrement et a démontré que malgré les grands projets géants de télescopes de l'espace, des télescopes géants terrestres aussi, les télescopes les modestes, les observatoires modestes avec des petits télescopes peuvent encore jouer un rôle important et pour l'observation comme complément de ce qui se passe, de ce qui est observé depuis l'espace, mais aussi et surtout pour la formation dont on a besoin dans notre région pour la formation, pour les stages, évidemment, et également pour l'ouverture vers le grand public. Merci encore et désolé pour le dépassement.